So welcome everybody worldwide. We're really looking forward to spending a good, just about an hour with you. And thank you for making yourself available. My name is Johannes Biermann. I'm President and CEO of aicas, and I'm your host today for this exciting webinar, which is a live webinar. You see those that are presenting here on the screen. We'll be talking about a topic that really is important in light of everything AI these days worldwide. Who wouldn't think about AI every day? We all do. But there is, of course, a topic to be considered, which is, what happens to the edge? So how do we secure the edge? How do we secure the traffic from cloud to edge? And that's really what we're talking about here as we discuss, practices around protecting ML model deployment in reality. So we expect a number of attendees from different regions here, which is great. And I look forward to engaging with you also. We'll come to a couple of logistical topics later on because we do have a Q&A session, which I will lead into in about 30 minutes or so. Meanwhile, AI is in everybody's thought. I thought we'd get started with maybe some comic book alternatives because what do we want to achieve here? Well, what we don't want to see is that after this meeting, you still experience your setbacks from not being able to get the right updates. This is what can happen basically when things aren't updating right. Robots behave weirdly. That's actually a real case from way back when in a real manufacturing environment, something went haywire. And things become very mission critical and they can become unsafe. You don't want to do that. And that's the same true as we now have approached the AI-driven world. Same thing if you're an automotive company, OTA updates need to work. You don't want to have things that don't update right and resulting in, for example, ADAS system not recognizing their surroundings. So these are real cases. And while we look at them, being funny, they really do have some real world implications. And what we as technology partners and you as partners or consumers in that system want to assure is that things are secure. So that's what we want to talk about today. We want to talk about some of the challenges that are specific to updating edge AI systems. Think about everything that's out there. How do we keep it secure? How do we keep the traffic to and from secure? We also want to showcase, well, how does that work? For example, if you look at an award-winning solution like we have just seen between aicas and Swissbit, the two partners joined here at the HIPS, have presented that at the Embedded World. How does that actually work? And what does a technical implementation look like? And get to a hands-on live demo, really hands-on. And we have for that, in fact, two great speakers here I'd like to introduce from two great companies. And one is Michael Ryman. He's the lead architect, product and solution architecture at aicas, has been with aicas for more than 10 years, has been, I would say, battle tested in projects with large and small companies, both in automotive as well as mobility and also industrial. And his specialty is really around software development for embedded systems. How do you embed basically technology into different IoT use cases? And he's also a trained practitioner in everything AI. Secondly, we have Roland Marx, who is the senior product manager for embedded IoT solutions and security of Swissbit. And he basically comes with an equally esteemed background, has worked as software developer for embedded solutions, specifically around security and IoT device management. He spent a lot of times, for example, in agriculture, as well as off-highway connected vehicle use cases around security. And since 2024 is focused on embedded IoT solutions for Swissbit. And with that, I'd like to point out the two companies here. One is aicas. aicas is a software supplier provider for embedded software, about 20 years old, a couple of years more, but let's say about 20 years young, and still counting. Real-time intelligence for embedded edge-to-cloud systems, very focused on edge software management, simplified and secure, making it easy. And thirdly, really a strong focus on remote edge data management that is both covering edge as well as cloud solutions. And Swissbit is a premier partner, European-based. In fact, the production is made in Germany here as a leading manufacturer for industrial data storage and security solutions. and also specialized in hardware firmware development that finds its way into advanced chip packaging. So two great companies that combined really speak to how we tackle such a solutioning approach for keeping AI systems secure. And so with that, I just want to get through a small logistics. You may see up on the top an area which is called F&A. This is synonymous for questions. So if you do have questions, please do record them in that chat that you see up there on your screen. And I will monitor those questions while we go through some of the discussions with Roland as well as Michael. And then at the end of the session, we'll do a summary Q&A. And you can feel free to enter questions as we go along. And there will also, I have been assured of it by my marketing staff, there will be a shared link sent to you later that you only will be privy to accessing so that you can do a recap of the presentation. So with that, I would say I'm going to hand it over, I think, to Michael. Michael, why don't you take us into the topic?
Yeah. Welcome to the topic and welcome from Karlsruhe offices. We are here in the world of updating ML models over the air securely. And what does that mean? The usual process lifecycle of an ML model consists of a loop that repeats over and over and over again. So usually when we speak of ML models, these models have been trained on a data set. And usually after the training, you do an evaluation with a part of the pre-labeled data to check whether the training was accurate. There's a lot of try and error in this process still, which makes it an interesting area of development as well as academics. We will today focus more on the practical parts, meaning how to get an ML model to where it is used. That step is called deployment. The usage often is called inference as well. Furthermore, to close the loop, you can derive information from the execution of the model on the device, collect that and send it back to the back end where you do the training. Training more expensive, inference less expensive, can be done on embedded devices nowadays. But you can use that data to improve your model, closing the loop, starting the next iteration of training and deployment. That's a pretty nice circle. We have visualized the whole process in an interactive presentation that I want to show to you now to actually give us the complete intro into what we will see during this webinar. Therefore, I will quickly change screens at my end. And you should now be with me on an interactive presentation with a pretty nice blue background of what we'll see today. So as said, the initial step is training the model. Usually you have tools like Python and TensorFlow in the place, or more elaborated tools in your tool chain that do the training. We then start our journey when the trained model is created and needs to be transported. We do some steps to guarantee security and privacy in here, which we will explain later on. And then we use our software management and configuration portal, EDP, to actually bring the trained model to where it belongs, so to the embedded devices where it is used. aicas software makes sure that it gets depackaged there. Swissbit makes sure that although in the depackaging, everything is secure, the system will never see the content of the model. And then we can use it for inference, data flowing in. The model in a second will start inferring what the data could have said to him or it. And then it will come to a result. Here, for example, it has guessed that we have a screw. All we will talk about today is how do we make the pipeline from the model being created and trained to the model being used as secure as possible. And for that, I hand over to Roland.
Thank you, Michael. So so we've seen the overall workflow, the overall aim that we want to do. So we want to be able to train a model and bring this securely to the device, and also maybe bring information back from the device to train the model better in the end. So let me allow you to also give some other reasons why we want to have updates, just also as a motivation. So on the left, you see a picture of many cars. And if you watch the video, you will see they will flash their headlights because they were just getting a software update. And this is an example of Tesla in this case, where they do software over the air deployment for bug fixing, to improve user experience and so on. And they get a much better time to market with this thing. So it's also very widely known to do these things over the air. So over a network communication and not via a USB stick, for example, where it's much easier to gain certain layers of security. And another very important thing is, so especially I would say in the European Union, where we now have the EU Cyber Resilience Act that's around the corner, software updates are also very important for vulnerability management. As most of products today are not really written by hand from scratch, but also have many open source components, and all of them from time to time will get more publicly known vulnerabilities that can be or could be exploited. So here you have to have a way to fix this. And the AI models, so this is more on the left side, on the improvement, on the usability, and also on the user experience of the products that you have there. But the right thing is more the real needed part for regulations, for example. And from my previous many projects in like we've heard before, so many agricultural projects where at all time somebody can turn the ignition key and you have no power at all. Internet connection, cellular connection can be gone every second. So if you consider these for also AI systems, so that it's maybe not in an industry, but maybe for in a remotely driving car or whatever. So you have a lot of requirements for the updates themselves. For the users, it should be with minimal downtime or no downtime at all, for example. It should be very cost effective, so you don't want to send hundreds of megabytes if you just want to patch a very small file, for example. But also you want to be able to automatically recover for all maybe uncertainties, like automatic recovery when update failed because of whatever reasons. Yeah. So here you need to develop stuff and have stuff in your embedded systems that make the system as robust as possible. And my focus also in this presentation will be on the security of this whole process, because also safety and robustness, this is more for accidents that could occur. Security is something where somebody from the outside might want to attack or manipulate your system or your processes, and what you have to be aware of and what you can do against this. And also software update management system. So overall later, you might want to know which of your model versions is deployed in which regions of the world, to also get an image of if you maybe need to do some updates somewhere. So let's have a look at the possible outcomes. So what could happen if software updates don't work as they should? Yeah. So one very good example is bricked devices. You see this a lot in the internet, maybe have seen this also at gas stations where there's a display which is not working anymore. And one example was, I think it's the company AEG, where they had a microwave and or a steam cooker, and they by mistake sent the wrong software to the wrong type of device, and because some sender readings were not there and over-the-air update was also deactivated with that update, the device was bricked. Yeah, so this is something that is accidentally happening. Yeah, so not really a security incident, but more security related would be maybe software manipulation. So if somebody wants to change the model and maybe see what's happening. Yeah, so consider this: if you have an ADAS system that should detect people, and maybe somebody's tweaking the model, but it's still deployed. Maybe some people are not detected, which could lead to casualties. And on the other side, so this is the manipulation of the product, but also your intellectual property, your development resources. Everything is somehow baked into this binary at the end, or into these files at the end. You don't want to be let this somebody have reverse engineered and so on. So you would like to protect these assets. And so some attack mechanisms or path that you have to consider would be, for example, adversary or man-in-the-middle attacks. Maybe you have heard this in the past. So this is if somebody can somehow be in the line of the communication, intercept your asset, tweak it, change it, and then send it over. There are pretty good measures what you can do against this. For example, mutual TLS encryption or authentication using a PKI to really see what is who is your communication partner, using private key cryptography. But on embedded systems, as we see it later, so we used an example with the Raspberry Pi, some systems are not really hardened against attacks on these root of trust that you need, for example, for a PKI. So if somebody can manipulate your root certificates, then also these man-in-the-middle attacks get much easier. So that's one thing. And the third part, the improper security, meaning not to have the wrong cryptographic algorithm, but to use it maybe not perfectly or state-of-the-art in an embedded system, which would be you use a secure element or HSM, TPM, how you might call them. They all have certain properties that the private keys that are generated inside cannot get out, so that you cannot duplicate them, and an attacker can use them and maybe then try to log in into your backend, as well as side channel hardening, so that an attacker cannot retract or retrieve the key by maybe measuring power fluctuations and stuff like this. So these are, I would say, 3 very easy and common things that you should be aware of and that you should protect your products for or against. And with this, I would like to also directly hand over to Michael, who will give some additions also in respect to AI models.
Thanks, Roland. That was already pretty creepy and pretty common. And I will add a little bit to the fright of our dear auditors by specifying how those attacks work on ML models and the specific characteristics that add when sending AI models over the cloud. You already mentioned man-in-the-middle attacks and model manipulation. All of this applies to software as it applies to ML models, because in that regard, ML models and software are really just the same. Also, you can always downgrade the model with an older version to then exploit vulnerabilities if you don't harden your system against that. Obviously, you want to transmit nothing in the open. You already mentioned a public key infrastructure and mutual authentication to actually encrypt the channel between the backend and the device. So if you transmit something in the open, an attacker could simply look at your model, extract the weights, and by this kind of destroy your business value by copying your model. Same if he can get your model and use it. He can use it for his purpose. He could resell it. He could train a model similar to yours, and your IP is gone. Or worse, he could even drive an attack on your systems by creating something similar. And last but not least, there's also the possibility of looking at a model in place to recover the training data. So usually the training data resides in the backend, but some of it makes its way into the internal structures of the model. And if you are able to reverse engineer the model for getting to the training data, you have further problems. Like, in the data, there may be sensitive data, not only of the company, so not only IP relevant, but also privacy relevant, because there could be user behavior in there. Or, speaking of picture-driven AI applications, so camera images and so on, there could simply be a private image encoded in the model that could be extracted from there and provide sensitive information. Now, how to harden against that? Well, for having a secure AI update solution, we must ensure that the solution is robust, meaning doesn't have faults on its own, that it's secure, that it keeps data privacy, but as you, Roland, also already said, we need to ensure that the operational integrity, meaning the software on the device where the whole process ends or basically is targeted at, is intact, based in a root of trust, and all software is anchored in this root of trust with a strong chain. That's the reason why our two companies, aicas and Swissbit, have put their intelligence together to actually create the system that we see and that was actually awarded before Embedded World by having our cloud software management portal in there, by having an AI agent running on our application management system in there, and by anchoring the whole solution in Swissbit's hardware security. And now it's the time to learn a little bit more about what Swissbit offers in hardware security.
Yeah, thanks for letting me quickly introduce this, and let me tell, this is something special. Yeah, it's a Swissbit special thing that we do, and I think you will not really find this somewhere else. And also, I'd like to mention that what we do here. So on the right, you see like one micro SD card, and in the below, I will explain you like what parts are inside. All these things we do in Berlin. Yeah, we produce these things in Berlin. We have our own fab, and also as from the introduction, so we come from industry flash devices. So not only these types that you see here on the left, but it's mainly always like high temperature, long endurance, and so on use cases, which are mainly related to flash, so storing data. But then some years later, we also augmented this whole portfolio of storing with security features. For example, by the usage of our own flash controller, so this is also our own company IP, we can decide what the host might do with the flash. So whether data can be readable or writable or is maybe not visible at all. Yeah, so these things are one layer of security, which is already quite great and called security level 2. But we also can do additional things, like I said before, these special created secure elements that we also then buy from Infineon, NXP, and so on, or on a customer basis, and that we can also integrate into one hardware form factor. And these things, they are certified and they are made to have private keys private, and also are resistant against these side channel attacks. So this is actually the special thing that we can do with our product. So we have access control and certain features that can protect the software that is stored on your boot medium, for example, but also to have this crypto material secured in the system. And for this demo, we used a Raspberry Pi. This is, I think, widely known platform, but it's also widely known for its not really by design security approach. So actually there's not much security at all. Everything is stored on the micro SD card normally. How this is working, how we can make this secure, I have other webinars. So let's here focus on the aicas use case. So here it's mainly it's the host system. It could be any ECU that you can think of for your use cases, or a robot control or an industrial control unit. And on it runs the Jamaica AMS microservice. As the root of trust or anchor for the root of trust, we have our iShield HSM, which has all these features, secure element and so on inside. And there is also the Edge device portal, which is needed for the management of handling and sending the images then to the device and seeing whether it was deployed and so on. Maybe just also one word, so as a good background. So there are different parts in your embedded system that you would like to update with different frequencies. For example, bootloaders, you only want to touch very barely, or you try to avoid to do bootloader updates because also they have a high potential of breaking your system. The operating system, I think there's you will not get around this. There will be always patches that you need to apply. So this is something that you will have to do. It's potentially easier, at least easier than the bootloader. Applications might be even easier because if maybe an application update fails, then also your device is not really bricked, so you can recover normally from these things quite quickly. And an interesting thing, which Michael will also talk about, is microservice updates, which is even a smaller portion of application and also gives you the great benefit that you can do this even during runtime, so without a reboot, for example. And so this one thing was with the time base, like when do you or how often do you need to do certain tasks? Let's also quickly have a look into what you would normally do to update an embedded system, or what you could do. So there are different approaches here and all have their pros and cons. Actually, file-based updates are not really great, I would say, but you could also patch just a file, patch a binary, bring it via FTP or whatever way to your system and run the application. So this would be at least possible. Another thing is doing packages. So this you find very often in the Linux world. So you do an apt get update and upgrade, and then many packages with the dependencies will be updated on the fly. And this is done in small chunks. So each application is one application package. Containerization is also very familiar because you have a lot of the dependencies of the applications inside of such a container. And also the dependency to the host system is only very, very low. So there are not many dependencies, but these things are quite big already. And even bigger would be things like file system image updates. So here we talk about hundreds of megabytes for a standard embedded system. So maybe 10 to 150 megabytes can be normal here. And if you just want to patch a small service, then yeah, using this way, you might have a lot of overhead of sending a lot of data over the air. And yeah, what Swissbit, what aicas can do here, I will just hand over again to Michael, and he can explain us the concept of the microservice updates and the architecture of the aicas system.
Exactly. Thanks, Roland. What you see now actually is the same picture that we just have seen in Roland's slide, slightly dimmed down, and you will see something new in there, which is the microservice runtime. So for embedded systems, aicas propagates a microservice architecture for a very good reason. As Roland already said, the lower you get, the harder and the more risky updates become. So we want to do the updates as lightweight as possible, meaning we compose applications from multiple minimal components, which means if we want to update one of those components, we only need to update this component, which makes the update ultimately slim, meaning we save data when transmitting the update, and although the impact on the system is minimally slim, meaning we can run the other applications or even the application where we update a microservice in without stopping it. So there is no interruption of the critical functionality of the system. In addition to that, implying a microservice runtime at the edge gives further advantages, like we can control what our applications and our microservices are doing inside. We always call that a secure environment or a walled garden with a door. What gives what does that setup give to us? Well, we can protect the memory of the system. That's the main source. Over 80% of all issues in remote and public internet connected systems come from invalid memory access. We can authenticate the applications and bundles that run in us, and we can authorize them before entering the system. And last but not least, we can assign resource budgets on CPU, on bandwidth of network connection, on memory that are assigned to the applications, and the application cannot exceed those budgets. All of this would be a nice green box. But as said before, that green box needs to integrate into the system securely. And that's where Swissbit comes into play as well. So where do we two interoperate? We use Swissbit here for checking the integrity of the system at boot time. By this, we form a chain of trust from the microservice runtime into the cryptographic material that is stored in Swissbit hardware. And then we can use this cryptographic material to actually restrict access to the system, preventing anything that hasn't been validated or authorized from entering the system, and also from exceeding its allowances. So far for the explanation what the two companies do. Now I will very briefly introduce you to the example that we actually display in the live demo in this use case. And the ML use case that we have chosen here is basically a pretty simple 101 example from the TensorFlow tutorials. We want an AI application to categorize things, here clothes, and those are presented by a camera image. We have predefined categories. You see 20 of them, 25 of them. And the task is to sort the image into a category. And therefore, we want to use an artificial neural network. Quick intro to neural networks, just in case that you haven't heard of them, most probably you have by now. A neural network basically is a network, as the name says, which models a complex statistical function. It does so in having nodes which execute a smaller function and weights that are trained. The idea behind the neural network comes from the human body. So you will find a mimicked spine here. In our very example, we use a neural network to consume the input from the camera, which is 784 pixels grayscale image. And then, as said, the output will be a category from the ones I've shown before. And the model will give us a likelihood on how sure it is that the category was hit. Getting back to the very beginning, we have introduced that the ML model undergoes a life cycle that really is a cycle of train, deploy, use, observe, retrain, deploy, use, observe, and so on. That cycle carries the name MLOps, similar to DevOps. So our solution doesn't only secure the update, but also automates the whole process from training to getting new data. For today, we will focus solely on the deployment step. As said before, this is the area down here from encrypting the model through packaging, deployment with aicas EDP to decryption and usage. And for that, I will actually stop the presentation now, since we'll go live.
But you see, here's Johannes, your host, just encouraging you to add any questions on the side, because we're approaching also the Q&A session. I saw one question from Bill there, which will be highlighted later. Go ahead and do that while Michael does the demo. Go ahead, Michael.
So just to give you a very brief feeling on how the actual demo here feels, and I know it's only a very small example for ML training, ML modeling, but you can actually run that yourself with the links that you have seen on the slide before. So we will start training a model here, if I would type the command correctly. You see common tools, Python, TensorFlow, and the training will start momentarily. And what you will get is images that depict your training like this. So that is the internal representation of, I would guess, a boot that is used in the training of the model. The model then is created. Here you see the categories that you have seen on the slide before. And then it automatically gets, yeah, that's the training starting. Then it automatically gets uploaded to our software configuration platform. I have torn the automated process apart for you so that we can follow these single steps in there. Introducing aicas EDP. aicas EDP is the software configuration portal by aicas that we use for sending our small microservice application building blocks to edge systems, managing massive fleets of edge systems, mostly cars, but also industrial systems in this platform. And as you can see, I have created some devices in here, mostly for this demo, running on different platforms. And also for the sake of the demo, I have something that I can present easily on my screen, which actually is this device, which runs our Jamaica AMS. Jamaica AMS, the application management system, as said. Special sauce here, we can support multiple platforms. You see some on the screen, Linux, Windows, obviously, but then also embedded real-time systems like QNX, like VxWorks, like the ARM variants of Linux and every homebrew Linux there is, and some very exotic things like OS 9. That's actually the platform capabilities that aicas brings for embedded edge systems. Now, having this device from the remote server, I, by hand now, it runs completely automatically as that, can install my newly trained ML model. We will see the device reacting in a second. At least I hope so. There we go. Device has been downloaded, and now the inference already starts. Our AI agent has put the model into place, has decrypted the content, and now we will see how inference looks. So there we already see the model in action, and that's the result. He has received the image of an ankle boot, and it's pretty sure it's an ankle boot, and that's correct. We have a very interesting case in this model. So here we have the case that shouldn't happen if the ML model is trained correctly. So we have the image of a sneaker, but the model is absolutely sure it's a bag. It's not. Last but not least, a representation of 25 samples. So I can't count today. It's actually 15 samples, and 14 out of them are are categorized correctly. And as seen before, we have that one outlier, which would now could bring a human user of the system to the idea of retraining the model or training the model further. And with that, we can conclude the live demo. Going back into presentation mode. What have we seen now? We have seen half an MLOps loop, and we know what that is now. So we have seen training, encryption, secure deployment, decryption, and inference with a model, a pretty simple one. And we have excluded, by the design that we applied, certain threats. We prevented the model from manipulation. We have protected the data that is in the model. We had a really easy way here. Well, it was more complicated than the solution we provide because, as said, the solution is completely automated. So you just trigger the training and the rest just flows. And by this, we can guarantee that your ML model update is secure and doesn't endanger the reputation of your company, its value, its data, or its revenue. How did we achieve that? Well, we had three major components. The edge device portal for the actual deployment and the automation, the application management system on the edge for executing everything that needs to be executed on the edge, and we anchored that in the great hardware capabilities that the Swissbit USB CQ model provided to the solution.
If I may add, so this was one really good example of retrofitting security. Yeah, so there was a system, an embedded system that was not designed to do these things. Yeah, a Raspberry Pi is not really secure by design, but we showed that we can do this model deployment, and also, so if you're locally physically attacking this device, you will not be able to retrieve the files, even not from the micro SD card and so on. So this is something which you should also consider with all the regulations coming up. So if you might not have a system that is built secure by design, there are also options with the right hardware to harden this.
So Roland, probably a question on many attendees' minds is how easy is that to actually set up? If you took the two components from aicas and Swissbit, what amount of work would you have to put into that from your perspective as a practitioner?
So actually, I did not deploy the EDP or the Jamaica AMS myself.
Okay,
so this
Michael, maybe the combo.
I think Michael has to say.
Yeah. Go ahead, Michael.
Yeah, actually, we did that with my team, and agreedly, my team has quite some experience with aicas' products. But no, EDP actually is provided by aicas, either installed in customer's account or provided as a service for use in demo use cases and trial use cases. Jamaica AMS on the device basically is a copy over. So I myself, but I'm not the best the best voice here. I myself am always impressed how flawlessly Jamaica AMS installs on systems. That's really a pleasure. So actually, and sorry, Roland, for saying so, most of the efforts was integrating with the boot of Swissbit, which was perfectly straightforward, and then configuring the cryptographic material.
So the answer is actually it's not too difficult, and that's probably a good answer for the audience. So I think we're wrapping up the content section. So we're getting to the Q&A, right? About that. So what I would like to say is to the participants, I see about 44 in there. Go ahead and put in your questions in the F&A area, Q&A area on the right, on the top bar. But we do have a question already from Bill, who basically asked the following. I mean, he basically said, good overview of the cloud to edge software, ML update pain points. And I know what he was relating to, but he's asking the question, for the AI life cycle shown at the beginning, what are the similar pain points for the data feedback part of the loop? Does aicas also address these data-related pain points? Michael?
I will quickly use this slide to answer your question, Bill. Actually, aicas is just on the launch for providing a complete data configuration platform, which we will call EDG. With that platform that is not only targeted at ML use cases, but on anything that is data, the user can configure which data to get very, very easily and from the cloud side. Again, we focus on efficiency here, wanting to save cost at the user by not sending every single bit of data, but only the one that matters. And aicas now has a 20+ years history of integrating into edge systems. And the most part of our implications actually deal with data. And what was valid for the channel from the backend to the device is valid for the channel from the device to the backend as well. So you want to make sure, absolutely sure, that the data doesn't leak to anywhere. And here, encryption and mutual authentication, as well as authenticating and proving the intactness of the device, comes into play. That's why also here the combination of aicas and Swissbit is a strong one.
Okay, Roland, did you want to add to that?
No, but I think I really, so one thing is also this zero trust, so that you can also and I think Michael told this once to me, so you can also think of, you do your model and you upload it to the cloud, and you can be sure that nobody in the cloud will actually see the data inside. It is encrypted, and not only in transport, but also at rest if it needs to be like stored immediately because your device might not be up. So this is also strong, so that you don't just use a TLS channel. This is, I would say, pretty good practice, yeah, and everybody should do this, and we do. But also that the model itself is encrypted and also authenticated, so that you can really double check if everything is correct, if it's from the right entity that you thought it would be from, and nobody in between, not even your own system administrators, can see or can look inside.
Okay, got a second question then. So that ties a bit into some of the aspects you were talking about, Michael, you were mentioning, but also Roland. Yeah, we have a question from Dave Bennett. And, that's one of those questions which we always like because, prove it to us, which says basically, can you give specific examples of how the solution avoids cost and lost revenue? So how does it help, to avoid cost and losing revenue? Michael, you want to start?
Well, the biggest cost saving we have here was presented by Roland on his update slide. The higher in a system architecture you can settle functionality, the easier it becomes to update. The easier it becomes to update, the faster it becomes to develop, meaning you're saving a lot of time before or when you want to enter the market. So deploying and developing applications, especially ML applications, with the microservice approach of aicas is swift. There are numbers from the literature which say ×2. There are numbers from our customers that say ×8. And having that in a robust system with microservices where you actually, if you find an issue with your system, can update only a small component and don't have to refresh the whole system, is yet another huge cost saver.
Mm-hmm. Okay, Roland, what's your thought on that? I know IP protection plays a big role in that, certainly on what you access control, those kinds of things. So, Roland, what would come to your mind in terms of avoiding cost and lost revenue from a hardware?
Yeah, so if I think of avoiding cost, then it's also quite hard to like give real data breach examples where you know exactly like what was lost or what revenue or what image of the company might got lost or yeah. So these things, I think this is hard to tell, but at least though the operational costs or the operational ease that you get with an automated system. So everybody's talking about CI/CD. Yeah? So you have this here built up and ready for you. You don't need to do anything here. Yeah. So it's a CI/CD system that uses secure transport mechanisms and state-of-the-art security. I think this is one real good example. The question is, when is this the most when does this have the biggest benefit for you? While you're in the development phase of your product, or maybe in the after production phase, or so I think later it might be not so relevant to do these very quick updates like Michael said, but mainly in the development or in the early stages of your products. I think this really matters, and there you really have also the biggest revenue in terms of customer success and customer happiness.
Okay, good. So I'm looking at still participants. If you want to add further questions, we still have a couple of minutes. So one of the things that's of course on my mind is and probably people would think about that is how do you get hold of these solutions? I mean, you just reach out to the two of you and you get the same demo that we've just seen to explore it, or what's the best way to get to the aicas and Swissbit organizations to actually obtain a real feel for what they can do in their use case?
Maybe let me start, because I think
go ahead.
Is quite easy. So we have a network of distributors and partners that can help you with getting the hardware itself. You find this on our website, and you can also contact our sales team via sales@swissbit.com. We have a lot of tutorial material for these, also securing Raspberry Pi solutions, explain how everything is working. So that's, I would say, the first step. And if you want to do the solution together, then you just take maybe our basic blocks for the secure Raspberry Pi or secure embedded Linux system and add on top the aicas solution. And then where you can get that, I think Michael can tell.
Yeah, I'm definitely an eyewitness for the tutorials of Swissbit. They are really approachable. And if you want more information about the complete solution, want to have a deeper dive into it, want to get the components into your hand for experimenting with them, or just want to know more about one of the aicas products that is baked into the solution, just contact sales at aicas. Stefan Sieber, who is with us on the call, will be happy to point you to the right persons in aicas. And we also have a quite a nice gimmick or giveaway for you as a surprise. That is the part that most probably Johannes will introduce now, since I see him knocking on my door for getting the screen.
Yeah, that's correct, actually. And I just want to share this out with everybody here. So I'm going to go back to my screen view. Hopefully the right slide comes up. It doesn't, so that's let me just go here. Okay, hang on. See, this is what happens when you're at the last slide, basically. So I just want to point out the last slide. So Michael, maybe you can share it from your side, because mine seems to be frozen on that side. So that's
I will.
So that's a little glitch. So bottom line is, how can you get hold of the information that was shared in this webinar here? Well, number one is we have your name as you registered, and we want to be sure that you'll be given preferred access to the webinar recording. We recorded it. And so watch your email inbox, and you will get an email from us, from the aicas email. and with the link, and you can actually review the presentation, take screenshots, whatever you like, basically. In the meantime, what you can also do is there is actually the demo itself displayed on YouTube. The link is on the left side if you want to make a screenshot copy of it. And you can go on YouTube, type in secure ML deployment for edge devices, and you'll find the aicas and Swissbit joint demo. This is exactly the one that was awarded the Best in Show award on the floor at the Embedded World in Nuremberg a couple of weeks ago. So those are the two. Secondly, if you continue on one more slide, Michael, you will get preferred here because you participate in this call, free one-on-one consultation. So we'll be happy to have a member of the Swissbit and aicas staff. One is mentioned here, that is Stefan Sievers at aicas.com. As you can see at the bottom, the QR code is also displayed. You can reach out to him and vice versa, and we can tailor, and certainly they will be able to guide you on a specific solution specific to your needs and your industry or your use case that you have. So those are the two ways to get in touch. And with that, I would say thank you very much to Roland Marx from Swissbit and Michael Reimann from aicas. Thank you very much for the organizing team, and thank you for your time everywhere in the world, wherever you are, for your participation and your interest in this webinar about secure AI at the edge. Thank you very much, and have a good day or good night. Bye-bye.